Okay. So here's the problem we're going to look at. Are we allowed to have the word log written on one side twice? No. So what should we do? Condense it. It's a minus problem. So it's going to be a fraction. That's division. So we're going to write log base 5 one time. And then we're going to have a fraction. And what goes on top, what goes on bottom? Okay. And then what do we do? We can do that, but I wouldn't do that yet. It could be helpful. It might not be helpful. But we have to do something first. We're going to do a base of 5. Why are we going to do a base of 5? Get rid of the log. So we're going to do base of 5, base of 5. And base of 5 to an exponent of 0 is what? 1. So we've got 5x plus 5 over x squared minus 1 equals 1. And then what should we do? So just because you can factor it doesn't mean it's helpful. Do we want this to be a fraction? No. So how do we get it to stop being a fraction? We're going to take the bottom, we're just going to multiply it to the other side. So I'll multiply the x squared minus 1, multiply by x squared minus 1. So 5x plus 5 equals 1 times x squared minus 1. It just stays x squared minus 1. So this is factorable, but factors at this point would not help you. The reason we don't want to factor it is because we only factor things when the other side of the equal sign is 0. So if we look at this and we say, oh, that's difference of squares, let me go ahead and factor it, it's not going to be helpful because this over here is not 0 right now. Does that make sense? Okay. So the x squared does tell us we're going to have to factor to solve this, but we shouldn't do it yet. What do we need to do first? Yeah, we're going to have to subtract stuff. We're going to have to make it equal 0 before we start factoring. So I'm going to subtract the 5 over. I'm going to subtract the 5x over. I'm going to make this whole thing 0 out first. And then what do I have? So at this point it's ready to factor. This is also factorable, right? X squared minus 1 could factor, but so can this. So we're looking for two numbers that multiply to negative 6 and add to negative 5. One positive number, one negative number to multiply to a negative. Negative 6 and 1. So our parentheses are x minus 6, x plus 1. And then our solutions would be x equals 6, x equals negative 1. We don't know for sure that both of those are going to work, though, so we got to plug them in. So I'm going to take the 6, store it as x in my calculator, and then type the problem in exactly the way it looks in the original problem. So I hit math, up, up. That's how I get to a log base 5. Math up, up. Log base 5 of 5x plus 5 minus math up, up. Log base 5 of x squared minus 1. And I just want to make sure that equals 0. And it does, so 6 is a good answer. And then I'm going to do negative 1 stored as x. And I don't want to retype it, I just want to plug that new x value in, so I'm going to copy paste it. And this one doesn't work. So 6 is a good answer, negative 1 is not. Okay. Are there any other problems on the sheet you want me to find one similar to? What about on the back? On the other side, one like S? Okay. One like S. Let me see. I don't know if I have one that's a third. Okay, let's go ahead and just start letter S so you guys can see how you would deal with the third on this one, since that's the part that makes letter S a little bit weird, is that exponent of 3. So in letter S, it starts off pretty simple because you only have the word log one time. So we don't have any properties of logs that we have to do. We don't have to condense it down. It's already condensed down. So what would be our first step to get rid of the log? Yeah, base of 2 on each side. Two to the 6th. Anyone know what that is? 64? Okay. Yeah, it's a base of 2 with an exponent of 6 because you're putting the base in. 2 to the 6. 2 times 2 times 2, 6 times, yeah. So 2 to the 6th is 64. And then what would we do to keep going to solve this? Cube root, yeah. So third root. Anyone know what the third root of 64 is? 4, yeah, and if you don't remember that on your calculator, to get to the third root, you just hit the math button, and it's option 4. So third root of 64 is 4, so we've got x minus 3 is 4, and then x equals 7. Okay. Which number did we want on the other side? 11. Okay. Okay, we're going to go ahead and do 11 together because I don't have an example like that one. let's go back and double check the answer 7. Okay, so we've got 7, store it as x, and then we're going to do math, up, log base 2, not 7, x minus 3 to the third. Oh, you know what it'd be is we can't, so here's how we have to type this one in to make sure we're not doing the whole thing to the third. I think we might need an extra set of parentheses to the third. Yeah. Is that different than how you were typing it? Yeah. That's what it is. Yeah. Yeah, because when you put it into the calculator has an extra set of parentheses that your paper does not, basically. Because your paper is always like it just has an X here in your paper, but your calculator would put parentheses there. Your paper just has a 9, but your calculator would put parentheses there. So if you think about it, your calculator always has an extra set of parentheses. Yeah. Yeah, that one's weird when you plug it back in. Yeah. Okay. All right, let's go ahead and flip it over and do number 11. All right, so this one, we just have to be careful of our exponential rules to make sure that we remember how the rules work and that we can think about what happens when you multiply fractions together. So I'm going to leave the e to the 9 on the left side. Since I'm multiplying something by a fraction, I'm going to go ahead and make this a fraction as well. Okay, so somebody tell me, if you have an exponent to an exponent, what do you do? Exponent to an exponent? You multiply them. So x times 3 is 3x. Okay, so we have e to the 9 equals e to the 3x over 1 times 1 over e to the 9. Okay? Now we are multiplying fractions together. How do we multiply fractions together? We just multiply straight across. You only do keep, change, flip if you're dividing fractions. So if you're multiplying fractions, you just go straight across. So we have e to the 9 equals e to the 3x on top, e to the 9 on the bottom. Okay, now we're doing division next, e to the 3x, e to the 9. What's the rule with division? You subtract your exponents. It's easier if it's something like x to the 7 over x to the 3, because if this was the case, what would you say your answer was? X to the 4th. That's really easy for a lot of people. You just go like, oh, how many, there's 3 x's on the bottom that cancel with 3 x's on the top. You got 4 left over. That makes a little bit more sense. When you do something like this, you can't actually say that some of them cancel out. You're just going to do straight subtraction. So when we do subtraction on the right side, we're going to say on the left side we still have e to the 9. On the right side, we're going to have e to the 3x minus 9. We're going to subtract e to the 3x minus 9 because the rule is subtraction. 3x minus 9. Now at this point, we have the same base on each side. So the bases don't really need to be there anymore. If the bases are the same, the exponents are going to be the same. Does that make sense? You just take the e's away, you don't need them. Like if I had e to the x equals e to the 2, what would you tell me x equals? You'd tell me it equals 2. Like that's a really easy equation to solve. You don't really need the e's. You'd be like, oh, x equals 2. That's obvious. Same thing here, it's just a slightly more difficult problem. Okay, so at this point we go, the x's are not helpful. We don't need them anymore. So now I'm going to ignore that the e's are there, and I'm going to say 9 equals 3x minus 9. And now I'm solving a really simple equation. So I'm going to take the 9, add it over to the other side. This is 18 equals 3x. Divide by 3, I get x equals 6. So this is actually not considered to be like a Math 4 level question. This is a Math 3 level question, because Math 3 is where you would have learned how to solve an exponential equation. This is called an exponential equation because it has exponents, it doesn't have logs. So this is using those exponential rules, which is something that you learn in Math 3. Or not learn in Math 3, but you learn in Math 2, and then you use that to solve stuff in Math 3. And it's okay if you didn't remember how to do that. Now, you do it again right here. So let's look at number 9. How are you going to multiply these two together? What do you do with the exponents when you're multiplying the two bases together? You add the exponents. So this would be e to the 4x. This one's not quite the same, though, because you don't have an e on both sides to cancel. So how are you going to get rid of a base of e? Yeah, you're going to log base e both sides, which is the same thing as doing an ln on both sides. So you're going to get rid of the base of e by doing a log base e on both sides, or an ln on both sides. Okay, I think that 11 is probably the most difficult as far as the exponential ones on that page. Are there any other ones that seem weird on that page? So we would do log base e on each side, log base e, which is the same thing as ln, right? And we get 4x equals log base e of 4, which is the same thing as ln of 4. And we just have to divide by 4. It's going to be a decimal. So ln 4 is a decimal, and you're going to do whatever ln 4 is divided by 4. Yeah, that decimal divided by 4. Okay, you guys feeling better about these? Okay, so I'm going to give you guys some time to work on the worksheet, and then towards the end of class, if we need to go over some more of them, we will. All right? Okay, so what did you start with? So you have ln, and there's a minus. So what's on the top, what's on the bottom? Okay, and then what did you do? So what's... So, because the way the cross multiplication works, if you actually like showed all the steps, 3 over 6x equals x over 8, is you would basically say on this side I'm multiplying by 8 to get it off the bottom of the fraction, and so it cancels out with this, so on this side I'm multiplying by 8, so see how you get the 3 times 8 is 24? And then on this side you're multiplying by 6x to get it off the bottom of the fraction, so over here you're multiplying by 6x, and that's where the 6x squared comes from. And that's why it's still an equation. So cross multiplication is like a gimmicky sort of thing to really just be getting stuff off the bottom of the fraction and moving it to the opposite side. Yeah. Okay.